All right, let's jump right into a topic that's, absolutely critical, but sometimes gets pushed to the side: error handling. This isn't just about stopping your programs from crashing. It's about taking your Python code from feeling kind of fragile to being genuinely resilient, making it truly professional grade. You know the feeling, right? You've been coding, you run your script, everything seems to be going just fine, and then poof, it just stops dead. No warning, no helpful message. It's super frustrating for us as developers, but imagine how much worse it is for an end user. And this right here, this is the core philosophy. You have to get this in your head. The goal is not to write code that never ever hits an error. It's impossible. You're going to get bad user input, a network connection is going to drop, a file will go missing. These things happen. The real goal, the pro move, is to anticipate them and handle them so well that your program just keeps on chugging along, totally in control. So, how do we get that control? Well, the good news is Python gives us a fantastic set of tools right out of the box. So let's start with the absolute bedrock of error handling. Think of this whole thing as your procedural safety net. The try block is where you put the code that might be a little risky. If something goes wrong in there, the program doesn't crash. No, it immediately jumps down to the accept block. Now, if everything goes perfectly, the else block gets to run. And then, no matter what happens, error or no error, the finally block always runs at the end. It's perfect for cleanup. Now, this is maybe the single biggest mistake people make. Using a bare accept is like using a blunderbuss. It just catches everything, including typos and other bugs you had no idea were there, and it just swallows them. It makes finding the real problem a nightmare. The professional way is to be a sniper. You target the specific exception you're expecting, like file found error. That way, your code stays predictable and you don't accidentally hide other problems. And you can be a sniper without making your code super repetitive. If you have a block of code that could fail in a couple of different but expected ways, maybe a value error or a type error, you can just group them together in a tuple in a single accept block. This keeps your code really clean while still avoiding that dangerous catch-all blunderbuss. Okay, so we've caught an error, we've stopped the crash. Are we done? Nope, not even close. This is where we shift our thinking from just surviving errors to actually using them to communicate, turning what could be a bug into a really useful feature for both our users and for us. Just think about the difference here from a user's perspective. Error occurred. What does that even mean? It's useless. It makes you feel like you did something wrong. But invalid email format, please try again. Ah, that's actionable. That's helpful feedback. It tells you exactly what happened and how you can fix it. That's a good user experience. But what about all the technical details? The stuff that's super useful for us, the developers, but would just confuse or scare a regular user. Well, that's what logging is for. It's like your own private detective. You can write the full, gnarly technical details of an error, stack trace and all, to a log file where the user never sees it. This lets you figure out what went wrong later without ever ruining the user's experience. Okay, time for a little bit of a paradigm shift. So far, we've been talking about catching errors that happen to our code. But truly robust professional code also knows when it's time to create its own errors. We do this with the raise keyword. So when your function gets some bad data, like a password that's way too short, it shouldn't just pretend everything's fine. It should actively raise a specific descriptive exception. This is a powerful way to communicate. It's your function basically putting its hand up and saying, hey, the code that called me, you gave me something I can't work with, and you need to deal with this. So let's see how these little building blocks fit into the bigger picture. We're going to zoom out now from just syntax and start thinking about the architecture of clean, resilient applications. You know, that try except block is so handy. It's really tempting to start using it for everything, but that can actually become an anti-pattern when you start using it for things that they aren't really errors. Take this classic example, using a try except block just to check if a key is in a dictionary. I mean, it works, but it's kind of clumsy. A key not being in a dictionary isn't some shocking, exceptional event. It's a normal thing that could happen. The clean, more Pythonic way is to just do a simple if key in my_dict check. It's easier to read, it's more direct, and it saves exceptions for truly exceptional situations. This leads to another really crucial architectural idea. Just because a function can catch an error doesn't mean it should. Imagine a low-level function that just reads a single line from a file. If it gets a network error, what's it supposed to do? Retry? use a default value, it has no idea. It doesn't have the context. The best thing it can do is let that exception bubble up to a higher level part of the program that does have the context to make a smart decision. Okay, here's another classic problem. Let's say you open a file or a database connection. You're planning to close it later. But what happens if an error occurs before you get to the line that closes it? You end up with a resource leak. So how can we guarantee that cleanup always happens? Python's answer to this is just so elegant. It's called a context manager, and we use it with the with statement. When you type with openfile.txt as f, you are making a deal with Python. You're saying, hey, handle this file for me. And Python guarantees that no matter what happens inside that block, even if a crazy error happens, that file will get closed properly at the end. It's automatic, clean, and prevents resource leaks. All right, we are on the home stretch. We've got the tools, we've talked about communication, and we've looked at the architecture. Now for that one last piece of the puzzle that makes sure our code is genuinely resilient. This sounds so obvious, but you'd be amazed how often it's forgotten. Your error handling logic is just more code, and that means it can have bugs too. You absolutely have to write tests that are designed to fail. Tests where you feed it bad data or try to open a file you know isn't there. And then you verify that your accept blocks and your logging are doing exactly what you think they're doing. So why do we go through all this? What's the payoff? Well, it's huge. First, we prevent those sudden, frustrating crashes we talked about at the very beginning. We create a way better experience for our users. We make our own lives so much easier by making debugging simpler with specific exceptions and detailed logs. And in the end, it's not just about fixing bugs. It's about a mindset that leads to cleaner, more professional, and way more maintainable software. So I'll leave you with this question to think about. It really isn't about having the most complex algorithm or the flashiest new feature. So often, the real difference, the mark of high-quality, professional-grade software, is how it behaves when things inevitably go wrong. It's all about that commitment to robustness and clarity. It's about mastering error handling,